Okay, so today we're going to work at 7.3, which is looking at sine and cosine graphs, and also changing the amplitude and the period. Tomorrow we'll do horizontal and vertical shifts. Today we're going to do horizontal and vertical stretches. So the first thing we want to do is look at the sine graph. Our parent functions here are going to be the y equals sine of x and y equals cosine of x. One thing you'll notice as we go through this lesson is there's a lot of skills that you're going to be using that you picked up when we did the unit earlier before Christmas with the translations and transformations of parent functions. We'll be using a lot of the same skills here, and I'll kind of point that out as we go through. One thing you'll notice as well is if you look at our graph, it's not like the normal coordinate plane that you think of. If you look at our function y equals sine x, what we're putting into the function is going to be an angle. So we're just going to use radians here. Sometimes you'll use degrees, but most likely you see it in radians. And so here we're going to be putting in an angle. So that's what our x value is, are these angles. And our y value, what you get out of the function, is the value of the trig function at that angle. Same thing with the cosine graph. This is our x, it's an angle. Y is what we're getting out. What we also want to look at is kind of the vocabulary we use to talk about these graphs. These are periodic functions. So that is a function that repeats a pattern of y values at regular intervals. So that means this function will keep repeating itself, as you can see from the sine and cosine graphs. They continue on in both directions, repeating pattern. They have a repeating pattern. And one cycle of that complete pattern looks like this. On the sine graph, this would be considered one cycle. After this, it repeats itself. On the cosine graph, one cycle starts high and ends high. On the sine graph, we start at 0 and end at 0. The period is the horizontal length of one cycle. So basically, how long does it take us to complete one cycle? So I can look at this on the sine graph. This is one period. This is how long it took us. It took us to 2 pi to complete one cycle. Here on the cosine graph, it also took us 2 pi. And the amplitude is half the distance between the maximum and the minimum of the y values of the function. How I think about amplitude is the distance of the peaks and the valleys of the graph. When you look at those curves, the maximum and the minimum, those distances from the middle. So if the x-axis is the middle, this distance here is my amplitude. You can also think about it as in the valleys, the minimums. That distance is our amplitude. On our cosine graph, this would be the amplitude. Here's the amplitude. So our amplitude on our parent graphs is 1. Amplitude is a distance, looking at the distance. So once again, that's going to be positive. We want to look at how this graph is derived. And this graph is derived by looking at the unit circle. And if we look at the points on our unit circle, if I look at these 4 kind of points, we refer back to these points a lot. And these kind of give us our critical points on our graph. If I look at this point, this is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. And these points occur at our axes. So if I look at the angles, this is at a 0 degree angle, or a 0 radian angle, pi over 2 radians, pi, 3 pi over 2, and then back to 2 pi. If I think about going around the circle, that's where these middle and highs and lows points come from. If I remember back to the unit circle that we did We said that the x value and the y value on our unit circle are really the cosine and sine at that angle. So at 0 radians, the cosine is 1 and the sine is 0. It's like the x and y value. So if I look at my graph, that's how I'm deriving these points. At 0 radians, we can see that our sine is equal to 0. Therefore, my sine graph always starts at 0. At pi over 2 radians, my sine is 1. So at pi over 2, I go up to 1. At pi radians, I'm back at 0. At 3 pi over 2, I go down to -1. And at 2 pi, I'm back at 0. So sine starts at 0, goes up, back to middle, down, back to middle. Those 5 points it's always going to have that same pattern. No matter what our amplitude or our period are, we will have that same pattern of middle, high, middle, low, middle. Cosine is the same thing. Cosine is now derived from our x values of our unit circle of those points. So at 0 radians, I start at 1. At pi over 2 radians, I'm at 0. At pi, I'm down at -1. At 3 pi over 2, I'm back at 0. And then I end back at 1. So cosine starts at 1. So starts high, goes middle, low, middle, high. If I look at the amplitude and period of our parent graphs, just quickly, we can see here is 1 cycle. We have a amplitude of 1. So we're always positive. And we have a period here. It starts at 0, it ends at 2 pi. So we have a period of 2 pi. This is for our parent function. Cosine looks like this. We have an amplitude here of 1, and we have a period here of 2 pi. So you're always thinking back to our parent graph of sine and cosine. Now we're going to add a vertical stretch or shrink and a horizontal stretch and shrink. So you might recall back from before Christmas that if we had something multiplied on the outside of our function, that was a vertical stretch or shrink. If it was greater than 1, that was a stretch. If it was between 0 and 1, that was a shrink. And if it's less than 1, we had to flip this over the x-axis. So if a is negative, we end up flipping our graph over the x-axis. My amplitude is always the distance, so my amplitude is going to be the absolute value of a. So it's always positive. The B is what changes our period, and that changes our horizontal stretch or shrink. So basically our curve will either happen, if I stretch it, that means it's going to take longer to do 1 cycle, so greater than 2 pi. If I horizontally shrink my graph, that means it's going to take less time to do, less distance to do 1 cycle of my curve. If B is greater than 1, so remember that back from before Christmas when we did the graphing unit, if we multiplied inside of our function, that horizontally changed. stretch or shrunk our function. And also remember, it was kind of the opposite of what we thought. So if b is greater than 1, we're going to shrink. If it's between 0 and 1, it's going to be a stretch. And if it's negative in there, that's going to flip over our y-axis because we're essentially reflecting our x values. So that flips over our y-axis. We're going to use a basic formula to figure out period. And we will use this as 2 pi over b. So to find the period, we'll take 2 pi and divide it by b. And that'll give us the period or the length of time. B really is talking about how many cycles there are in a length of 2 pi. So if we divide 2 pi by b, that gives us our period for one cycle. We'll now use these amplitude and period and these changes, our vertical and horizontal stretches, to graph sine and cosine graphs.